Hello grade 8, this is math lesson 1.4, estimating square roots. Okay, in the last few lessons we've been learning about square roots and squaring numbers and getting perfect squares. And some things we've learned is, square root of 9, that's the same thing as when we square root 3 times 3, which is the square root of 3 squared. Why? Because 3 times 3 is 9, 3 squared is 3 times 3. It's still all equal. And then if you square root the square of a number, all you get is that number as your answer. Same thing with 16 over here. 16 is 4 times 4, which is the same thing as 4 squared. So if you square root 4 squared, you are left with 4. Now, last lesson we were looking at how do you find the lengths of, lines that are going a little bit diagonally. Let's zoom in a bit here so you could actually see this a little better. These are those calculations you did before. But last lesson we were talking about when there's a diagonal line that's not on the grids, how do you measure those lengths? And we were getting answers like this, where it's a square root of a number that we can't really square. So what we're doing today is estimating. And estimating, it's not just guessing out of the blue like, oh, I think it's 2 or I think it's 3. It is a little bit of a calculated guess, but it's just a quick sort of thing where we know that the square root of 9 here is 3, and we know the square root of 16 here is 4, and we know that 11 is between 9 and 16. This is the one that's right below, and this is the one that's right above. So that means that we can figure out that if square root of 9 is 3 and square root of 16 is 4, then that means that 3 must be less than the square root of 11, because square root of 9 is less than the square root of 11. And we know that square root of 11 is less than the square root of 16, so that means the square root of 11 must also be less than 4, which is equal to 16. So that tells us that this square root of 11 has to be somewhere between 3 and 4. In other words, square root of 11, it has to be equal to 3 decimal something. And looking at this, 11, how close is it to 9? It's just 2 less, right? You can add 2 to 9 to get 11. And from 11 to 16, it's 11 plus 5 to get to 16. Which is 11 closer to? Is it closer to 9 or is it closer to 16? It's quite a bit closer to 9. In fact, it's 3/7 closer. So we'd estimate that it's, somewhere in a 3 decimal something. But less than 3 decimal 5 because it's closer to the lower number. So maybe somewhere around 3 decimal 3. Now, we can test our estimate out a couple different ways. And here's one way. Let's just zoom out a little bit and focus it again. If the square root of 11 is 3.3, that means if we were to square both of these numbers, we would get the same number, which we know that square root of 11 squared, these cancel out and we're left with 11, right? So if these are equal, then if we were to take 3.3 and square it, we should get 11, right? If this is true. But let's see what we actually get. Let's take our 3.3 and we're going to square it. In other words, we're going to go 3 decimal 3 times 3 decimal 3. 3 and 3 is 9. 3 times 3 is 9. Carry. 3 times 3 is 9. 3 times 3 is 9. No carrying needed. Just add it up. 9, 18, carry the 1, 10. And there's 1 decimal, 2 decimals, so 1, 2. Look here. We're pretty close, but we're still 11/10 too small. Right? So what we can then do is take another number. what if we decide instead, let's see 3.4. Let's bump it up, right? So this is too small, so that suggests that this number is too small, so let's bump it up a tenth. Go 3.4 times 3.4. 4 and 4 is 16, carry the 1. 3 times 4 is 12, plus 1 is 13. Put down a 0. 3 and 4, well, these are 3 and 4 is 12, still a 1. 3 and 3 is 9, plus 1 is 10. Add it up, 6. 3 and 2 is 5, 1, 1. And there's 2 decimals, so 2 decimals. Oh, we've gone too far. This is quite a bit higher than 11, which suggests to me that it's actually closer to this one than it is to this. So it's somewhere between 3.3 and 3.4. What's between those? Well, 3.35. Okay, let's multiply this by itself. Let's square it. Let's do 3.35 squared. 5 and 5 is 25. 5 and 3 is 15, 17. 5 and 3 is 15 plus 1 is 16. Put a 0. 3 and 5 is 15. 1. 3 and 3 is 9 plus 1 is 10. So put your 1. 3 is 10. Now we put 2 zeros. So the first time we put 1, second we put 2. And it's going to be, because this was 3 and all those, this will be those same digits, 5, 0, 0, 1. Add it up. 5, 12, carry the 1, 12, carry the 1, 2, 1, 1. How many decimals were there? 1, 2, 3, 4. So it's 1, 2, 3, 4. Oh, so we're above 11. We're closer to 11 than we were before. This was 5/10 and a bit off. This was 2/10 and a bit off. So it's still lower than this. Let's do another one here. What if we lower this to 3.32? Let's square that. 3.32 times 3.32. 2 and 2 is 4, 2 and 3 is 6, 2 and 3 is 6, 0. 3 and 2 is 6, 3 and 3 is 9, 3 and 3 is 9, 0, 0. And it's the same digits, so it's going to be these same 3, 6, 9, and 9. Add those up. 4, 12, 7, 16, 22. 20, 11. 4 decimals up here, so 4 decimal spots here. And we're getting really close. We have 11.0, but there's still some here. So perhaps this is 3.18 or something even closer. Sorry, 3.318. What if we go even further? Squared. Let's try that out. So we got 3.318 times 3.318. 8 and 8 is 64. 8 and 1 is 8. 8 times 1 is 8, plus 6 is 14. 8 times 3 is 24, 25. 8 times 3 is 24, plus 2 is 26. Put the 0, 1, and 8. That's just going to be these digits written out, because 1 times those numbers, that's what it is. 2 zeros this time. 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. 3 times 3 is 9. 3 times 3 is 9. And we put 3 zeros now. Why? Because we're 3 digits over from the first one. And these are the same digits, so these 4 digits here are going to be the same ones we write down. We'll add it up. 4, 12, carry the 1. 11, carry the 1. 7, 10, 19, carry the 1. 6, 9 is 15, 20, carry the 2. 20, carry the 2, and 11. So we're left with 6 decimal places up here. So 1, 2, 3, 4, 5, 6. We have 11.009124. We are very, very close there. In most cases, you would not notice the difference between 11 and 11.009, like 9 thousandths of a centimeter. You probably wouldn't even notice the difference. So in your assignment, you're going to see questions where it's like, are these good estimates for square root of 11? And it might say like 8.2. Would 8.2 be a good estimate for square root of 11? Absolutely not, because you know that it has to be somewhere between these two square roots, which means it has to be between 3 and 4. So if you put 3.3 or you put 3.4 or you put something like 3.2, that would be a good estimate because it's kind of in that range. And whereas there might be some questions where you need to go a lot more thorough, probably not even these last two. You'd probably only need to go this far to like 2 decimal places. It really depends on what sort of things you're actually doing with the math that determines whether you would or not go that far to estimate. But we could keep doing this if we wanted to get even further. We know that this is too much, right? So we could go to 3.3178 and try that, and keep going and keep getting more decimals and more decimals and more decimals. But I think we got more important things to do. Here's an example that might be a little more complicated than some of the ones you'll have that are similar, where you have to say one's less than the other, or they're equal, or put them in order from least to greatest. We can be starting to use these square root numbers as well here. So we've got 7, that I think we'll just leave 7 alone and not change that. And to estimate square root of 13, we know that it's going to be somewhere between square root of 9 and square root of 16, otherwise known as between 3 and 4. So we know that this is going to be 3 decimal something. And 13 is closer to 16 than it is to 9, so I'd estimate somewhere around 3.8 or 3.7. It wouldn't be below 3.5. And then you might have a fraction here where you've got 24 fifths. How many 5s go into 24? 5, 10, 15, 20. There's 4 of them. So that means it's going to be 4 decimal. 4 and 4 fifths. I skipped a step. Which 4 and 4 fifths, what's 4 fifths? That's the same thing as 4 and 8 tenths. And 4 and 8 tenths is 4.8. So we've got about 3.8, we've got 7, approximately equal to that, and 4.8. Order from least to greatest, well, it's going to be 3.8, 4.8, and then 7. And all these questions with this ordering always need to put it back to the proper form. So 7, and I like to put a line where I start to switch the order. 7 is what it was, so we're going to leave it as 7. 4.8 was 24 over 5. And 3.8 was square root of 13. So that is ordered from least to greatest. Most of the questions you'll see will just have 2 things, and it'll say which one's greater or less. Remember, greater than looks kind of like the G of greater, and less than looks kind of like the L from the word less. And then equals is like that. Greater than is the G thing, L is less, and then equals